All right, now we're going to get into the proofs that use CP/CTC. The difference between the proofs that use CP/CTC and the proofs that end with these, all right, with the postulates, is this. These ask you to prove two triangles are congruent, all right? The ones without the CP/CTC. The ones with the CP/CTC ask you to prove parts of those triangles. So that's what we have to do is you have to look. Are we proving triangles or are we proving parts of triangles? If we're proving parts of triangles, then it's going to be using CP/CTC. Now remember, what this means is that corresponding parts of congruent triangles are congruent. Otherwise, it's known as, hey, these two triangles are congruent, so all their parts have to also be congruent, or their corresponding parts to each other are also congruent. That's all I was trying to tell you. First thing, given. What's given to you? Well, angle D is congruent to angle C. We know that, okay? And then E is the midpoint, blah, blah, blah. E is the midpoint of AB. Okay, so let's label D and C. D is here, C is here. We labeled it. Second one, AE is congruent to BE. Well, we know this because it's being cut in half by E, and E is the midpoint of AB as it says in the given. So we can say this is congruent to this because of the definition of a midpoint. Alright, definition of a midpoint. Alright, next one, talking about vertical angles. So let's find the vertical angle. That's this one and this one. So these two are congruent. This is AED. So we say angle AED congruent to BEC, triangle BEC, because they're vertical angles. Last, AAS means that two triangles are congruent. We know that these two are congruent by AAS, so we're going to use these two triangles, which is triangle ADE is congruent to triangle BCE. Okay. So we've just proven that two triangles are congruent. Now we got to ask ourselves, why are BC and AD, the top and bottom lines, congruent? Well, because of CP/CTC, saying that since these two triangles are congruent, that means that all their corresponding parts are congruent. So that would mean that the top and the bottom will have to be congruent. So CP/CTC. That's why we abbreviated, because it's way too long to write out. Alright, last one. So we've got this right here. What's given to us? Well, what's given to us is angle L is congruent to angle N, and angle LKM is congruent to angle MKN. What it's saying is that these two are congruent and these two are congruent. Next thing says reflective property. Reflective property, remember, we're looking in a mirror. Our reflection's looking back at us, meaning it's the same thing. So we say that KM is congruent to KM. Last, or second to last, these two triangles are congruent now because of angle, angle, side. And now we know that BC, that shouldn't be BC and AD. That should be NK and LM. So NK should be N. K is congruent to L, M. The reason is because of CP/CTC. My bad. So replace this with this, just scratch it out, rewrite in case congruent to LM in this place, and you should have it done. But that's how you do CP/CTC. You're going to have one that uses this, and then you're going to have the other one like the 3 that we did before this. Once again, if you have any questions, ask in class. Otherwise, go into the next video if you need it. Thanks.